So in this video I'm going to sketch the modulus of 3e to the 4x minus 5, and on my sketch I want to include any y-intercepts and any x-intercepts. And I'm going to do my finished sketch on here, because what I'm going to do, I'm going to do some graph transformations of parts of this first to build up to my answer. So let's do a rough sketch first of 3e to the 4x. So let's just write 3e to the 4x. That's what we're going to do first. Now we know e to the 4x will approach 0 as x approaches negative infinity. So this will get close to 0 but never actually 0. So 3e to the 4x, if I sketch that, it's going to be close to the x-axis from negative infinity. Then it's going to intercept the y-axis when x is 0. So when x is 0, e to the 4x is e to the 0, which is 1. So 3e to the 4x will just be 1. Will be 3 when x is 0. So this point here is 0, 3. So that's my intercept. Now what I want to do is translate it down by 5 units by subtracting 5. So the whole graph will just slide down my axes here. So now as here, where y is 0, if I subtract 5, it's going to get close to y is minus 5. So this line will be along here, but not actually touch minus 5. Then this point 0, 3 will be sliding down 5 points. So then that will be at negative 2. So this is now going to go up here. And then when it gets past the y-axis, it's just going to continue like this, but from this point. So that's my graph now of 3e to the 4x minus 5. So this is what we're really interested in right now. So now what I want to do is do the modulus of that. Now the modulus of anything has to be 0 or greater. So if I have minus 2 in here, for example, I've got plus 2 by the modulus. It's the absolute value. So now what happens is, if I've got minus 5, for example, it then turns to positive 5. If I've got minus 1, it goes on this graph here as 1. So basically it's reflected in the x-axis. So this will be reflected in the x-axis on here. So at this point minus 5, if I reflect that in the x-axis, I'm looking at plus 5. So 1, 2, 3, 4, 5. That will now become my asymptote. And my asymptote is only required on the negative x-axis, because that's where this will be reflected to. So let's put that start of the sketch there. It's going to come down a little bit at some point. Now this point here at minus 2, if I reflect that in the x-axis, it's now going to end up at positive 2, which is this point here. So now my graph is going to come down and touch that point there. Okay, now at positive 2, I've still got this little bit here below the x-axis. So there'll be a little bit there which will carry on coming down like that, because it's going to be reflected. So that will flip up. And then when I get above the x-axis, those points there will just stay as they was on the original graph. So they're going to carry on and go off like that. So that's my graph. And that's the sketch of it. A little bit rough, but that'd be fine for now. So the y-intercepts. So there's only one point where it intercepts the y-axis, and that's going to be here at x is 0, y is 2. So that point there is 0, 2. But now I want to find this point here. Now to find this point, looking along my axis here, I don't know what x is, but I know that y is 0. So I'm going to set this to 0. So 3e to the 4x minus 5 equals 0. Now as it's not negative, I don't need to worry about the absolute value to solve, because I won't be needing that on that case at this point. So 3e to the 4x minus 5, to set it equal to 0. And now let's solve for x. So I've got 3e to the 4x equals 5. Divide both sides by 3. So I've got e to the 4x equals 5 over 3. And now to get this exponential with the 4x get the x out of it, I just take the natural log on both sides. So if I've got now log base e of e to the 4x, that would now equal log base e of 5 over 3. And I'll just put that in a bracket. So log base e of e, that just becomes 1. So now I'm just left with 4x. So 4x equals, I'm just going to write natural log now. Forget the e, we know natural log is base e. So natural log of 5/3. Okay. Now to get x on its own, just divide both sides by 4. So x equals 1/4 of the natural log of 5/3. Now if we plug this into our calculator, we get approximately 0.128. So we know that's going to be really close. So probably a little bit closer to the y-axis than what I've got on there. But that means I've actually nominated my point there in terms of this or this. So I'm going to write it in this one, because that's the exact value. So I can just type that into my calculator and that will give me my exact value to how many decimal places I may wish. So I've got 1/4 of natural log of 5/3 and y is 0. So that's my x-intercept, that's my y-intercept, and that's the kind of pattern that this will follow on my axes. Okay.